You most likely learned at school about congruent triangles, especially how to prove them. You need either 3 equal length sides between the triangles, known as SSS or side, 2 sides of equal length and an angle in between, known as SAS, 2 equal angle and an equal side, known as ASA or AAS, and you've probably been taught about the fact that you cannot prove congruency if the angle is not between the 2 sides. And if you learned in a public education system, you probably never learned why. A very common way to prove something in math is false is to find a counter-argument. Maybe there were a few things that weren't proven that way, but it's very rare. Because if A implies B, then not B implies not A. And if you find a not B that is A, you just prove that A implies B. So what is the counter-argument? Bam! The right inner triangle is clearly not congruent to the big triangle. However, if you look, they share 2 sides and an angle. That is why you can't prove a triangle with SSA. Note, there's confusing, very optional trigonometry approaching, so if you got the answer to your question, you don't have to watch or understand what's coming next. The angle you do need can be defined by this equation, which seems to return only one answer, because you can put it in a calculator and get one answer. Then the triangles would be congruent because the same angles and sides will be inputted. Well, it returns one answer because your calculator is lying to you. To get the second answer, just subtract the first from a right angle, and in any of these images, the one angle gets subtracted from a right angle, and that becomes itself plus 2 of the first minus the right angle. Confused? It's okay. All you need to know is the first part.